Well, good morning, everyone. So what I want to talk about today, before we get into vectors, is just there's loads and loads of really good work being uploaded by people. I know that it can be quite daunting, all the different things coming up on your class chart. So I understand Mr. Rogers has asked us all to, from now on, just set every day's work on that day, issued and due in that day, so that you're not full of all the stuff that you've got to do. And hopefully that'll take pressure off a bit. But there is a flip side to that for some of you, that if you've been ill for a couple of days, or for whatever reason you haven't been able to do the work, maybe you were on another subject or something else, I don't know, then you want to be able to look back and do it. And you might want to just do something again that you've done already and be able to find out where that is. So I am going to be doing something which I'll put together, I'm going to say within the next week, so don't expect it to happen tomorrow or today exactly, but at some time before the end of next week, which would be Friday the 22nd, definitely be done by then. I will be putting up somewhere where you can go to, where all the resources and all the videos that I have made since starting this whole lockdown experience, where everything is tailor-made towards giving you the best chance of getting the best score that you possibly can in the mock, which will be really great evidence for us to be able to give you the best centre assessed grade possible. But you do need to, if you have a bad experience in that, and I've got lots of evidence of all the work you've done, then that'll help mitigate that a bit. If you get a good exam, then that's great, but the best way to ensure you're going to get a good exam, as there's some very tricky questions in there, is to just do the work that I'm setting on here. And if you are confused by anything, as some of you have done, please email me. I might make another video, I might just do a little bit of whatever, but it'll all feed back into everything else that's going on and will help everyone. Right, so let's crack on with some vectors. If anything I've said's caused you any concern, please just email me. That's not meant to be the idea, it's meant to be making things easier. Finding the magnitude of vectors, that's what we're looking at today. So copy this down, pause the video and see if you can work out what you could do. Start by drawing a picture, I'd say. So what does magnitude mean? It means the actual size of the movement that you're going to make overall. So you might say that's 7, because I'm going to go 3 to the right and I'm going to go 1, 2, 3, 4 up. But actually that wouldn't be the answer, because what we're talking about the magnitude is the actual effective distance that we've gone. Yeah, we've described it by 3 to the right and 4 up, but in certain situations that might just be the way in which your computer program is telling something to go, and it will work out immediately that that means doing this. So if it was an aeroplane that was flying, that plane would just do that distance there. Now I've picked 3 and 4 for a very good reason. This is always going to give us a right-angled triangle, and hopefully we should all know that this is a Pythagorean triple, the most famous right-angled triangle of all, because you get the length of the hypotenuse by squaring both the shorter sides and then finding the square root of that, don't we? So that is the square root of 16 plus 9, which is the square root of 25, which is 5. You don't need to say plus or minus 5, because you couldn't have a negative distance of that triangle. That wouldn't make sense, so that would be positive 5. So here's our new problem. Write it down. When it says find the column vector AC, I recommend you make a drawing of both these two first of all, and then look to see what AC is, or you could just do some adding. It's up to you. So pause the video, have a go, and then I'll show you both ways. Right, so if we do it by drawing A, let's put a, how far are we going? I think that should work. If not, not to worry. Right, so 4 to the right, 1, 2, 3, 4. 3 down, 1, 2, 3. b must be there. So 4, -3 would look like that. And then if we go for BC with another colour, from 2 across 1, 2 to the right, and then up 4, 1, 2, 3, 4, C is over there. But what we're interested in is not either of those, but AC, which is that one there. So that is going to be AC, and that is 1, 2, 3, 4, 5, 6 across and 1 up. And you could do that just by saying, if we add these to this, 4 plus 2 gives me 6, 3 to the left or -3 plus 4 to the right or plus 4 is +1. So you could just do it that way. But it's a good idea to draw it out because it gives you an idea of what it's really saying. Otherwise you're just moving numbers around, aren't you? Not that there's anything wrong with that. We love moving numbers around. Right, so working out the magnitude of AC, can we do that all on here? We could do, couldn't we? So the magnitude is going to be, that's the hypotenuse of, let's put the right angle triangle in here. I could put it in over there if I wanted to. That's 1 long, isn't it? And that comes from the height. And that's 6 along. That comes from the movement there. So the magnitude of AC is going to be the square root of 6 squared plus 1 squared. 6 times 6 is 36. 1 times 1 is 30 is 1. So add them together gives you 37. Now 37 is a prime number, so we cannot simplify that. If it asked you for the exact magnitude, you would go with the root of 37. But if it doesn't ask you for the exact magnitude, then all you've got to do is say root 37 equals, press S to D, 6.082. So we could say that that equals 6.08 to 3 significant figures. Okay, a little bit of practice at that then. So here you've got your 2 vectors and you need to try and work out the magnitudes of these. You don't have to draw them each time if you don't want to, just have a go at adding them. Sorry about the terrible writing of 4 there. But all 4 of those, pause the video, give it a go, and in a moment I will check back with you with how I would do it. Right, so for A, 5 to the right, and then 9 up. Oh, that's going to be too many. I'm just going to say that that's 5 and say that that's 9. And then this is going to be 9 squared plus 5 squared. Oh, I did mean to say, if you could do all your answers on this as surds in their simplest form, that would be great. But you can use your calculator to do it, because this could come up easily. 9 squared plus 5 squared, well, that's the square root of 106, and even though it's an even number, if there's no square number apart from 1 that goes into that even number, it won't be possible to simplify it. On to the next one, 2b. So if we double 2b, that's going to be 6, 6. So if you think about it, 6 there and 6 there, the same on each. We're going to be looking at the square root of 6 squared plus 6 squared, which is root 72. Now, root 72 is 2 times 36. So that means 2 root 6 should be what you get for that. Let's just double check that, shall we? Root 72, yeah, 6 root 2. Oh, I've done it the wrong way round. 6 times root 2. Yes, so we are looking at the square root of 36 times the square root of 2, aren't we? And it's the root of 36 that is 6, so that's why it's 6 root 2. So do be careful, don't rush things like I just did. Right, 5 plus 3 and 9 plus 3 is going to give us 8 over 12. So we are looking at the square root of 144 plus 64. Put that in your calculator and press and there we go, it's done it for us straight away there, 4 root 13. So 16 would have been a factor of whatever that made, 208. Yeah. Okay, on to the last one, A take B. So we are looking at 5 take 3, which is 2, and 9 take 3, which is 6. So our magnitude is going to be the square root of 6 squared plus 2 squared, which is the square root of 40. And that is root 10 times root 4, isn't it? Because we know the square root of 4 being a square number, so that's going to give us 2 root 10. Now that you know how to add and multiply vectors and make pictures of them, it's time to start thinking about, and also find the magnitude of them, it's time to start thinking about the kind of questions that you're going to get. And they're all to do with shapes and moving around shapes. Parallelograms, triangles, and trapeziums are the favourites. So just to start us off with this, I'd like you to just draw a parallelogram down like I have, and I want you to think about it, and I want you to work out which lines. I should have written which line segments, really, because a line goes on forever and a segment is just each part. So which line segments, and I want you to identify as many as you can, are parallel first of all. So which ones are parallel? And hopefully you've got A, B and DC, and also BC and AD. Now they're the only ones that are going to be parallel. So AD is parallel with BC, and what that means in terms of vectors is the same vector that moves you from D to A will also move you from C to B, and the negative of the one that goes from D to A will take you from B to C or A to D. We also need to know the equal lengths, because that's going to help when we start combining things together as well. So that's what I'd like you to identify next. How many equal line segments can you find? Right, so I'm going to do a single stroke across there and there. AB and DC are equal. AD and BC are equal. I'm going to come in with a different colour here and say the midpoint. This line here is not the same length as that. This is clearly longer, isn't it? The acute angles are equal and opposite, and that diagonal is going to be longer than the ones with the obtuse angles in. But what we can say is the midpoint is going to cut them both in half. So that is the same length as that, and AM is the same length as MC. And that sort of realization is going to be important going forward. And I'm just going to introduce you to one or possibly even two more of those before then starting to look at some proper exam style questions next time. Right, so here we've got a trapezium, and write it down and have a go if you can. What do you reckon? This is the part which is quite easy. This is rated as grade 8, grade 9 stuff, but there will be bits coming up which will make your brains hum a bit. This bit, quite a lot of people find really quite easy and obvious. If you don't worry, just keep at it. It'll come to you. So I've got to get from A to C, but I'm only allowed to use this vector here, A, and if you've got that little arrow, that means for that whole line that you can see, that line segment you can see. B is that, C is that. So to get from A to C, which is that, isn't it? I can get there effectively by doing that and then that, which is just A plus B. Then when it comes to getting from A to D, I can't go straight along there, so I'm going to have to do that, add that, add that. If I knew what these were as column vectors, I could add them together and then say what that was, just as a straight horizontal motion, couldn't I? But I can't, so I'm going to have to say it right. If I did know what they were, I would add these together. And the very last one then, from D to B. Now this is going back the other way, isn't it? From D to B, we want to do that. So we're going to need to go there, which is negative C. And then we're going to have to do that, which is negative B, because we're moving against the arrow. So that would be equals take B, take C. Or you could say minus, and you could put a 1 in there if you wanted, but you don't need to, B plus C. So just taking the whole of that, doing the opposite of that whole movement. Right, so we're going to do one more of those and then call it a day. Right, so copy this down. I've put some different colour in just to make it a little bit clearer. So ABC is a triangle. That's important. That's so that you know that's all a straight line, but nothing more than that. P is the midpoint of the line from A to C, and you need to write down the vectors for AC, BP and BC, just using these shifts of the A like that and the B like that, or the negatives of them. Okay, pause the video, give it a go. So from A to C, well, if that's half the length, that must be 2 shifts of B, so it's just 2B. From B to P, well, that's dead easy. That's just A add B. And the last one, from B all the way to C, all you're having to do is your A and then adding that whole bit from there to there, which is 2B, wasn't it? And that's all we're talking about for today, folks. Hopefully that's come through loud and clear, and tomorrow we'll start doing some slightly tricky, the sorts of things that you're going to see in an exam.